Welcome to the KYAI Pod. We've got Rohit joining us, in addition to the usual crew, myself and Clay. It's 2026, and one of the biggest challenges the market's facing is memory capacity constraints. OpenAI made an incredible deal last year and went to Korea and bought 40% of the world's wafer outs in memory, which is causing a massive shortage, not to mention the increased uses of memory driven by AI. Both you wanting to interact more with AI, storing more context in AI, doing more advanced projects with AI that fills up that KV cache envelope, or deploying a agentic RAG architecture that pulls up some DRAM and VRAM space, or just autonomous agents that are just going out running 24/7. And you want the traceability and context, and you're not just going to burn through all their work without storing it and giving them a ton of context to be successful as they work as your autonomous agents. So huge market right now as it pertains to memory shortage. The cool thing is Rohit's been working on a couple of techniques to help with that challenge. So it turns out there's a couple of open source and key software initiatives that allow you to dramatically lower your memory footprint while retaining the context necessary to deploy AI and high fidelity. So Rohit, you want to give us some context on what you've been working on the last few months?
Yeah, I think Steen, you summed up the problem. So the problem being, once we compute the KV cache for an already seen prompt, the GPU, if it's on the GPU cycles, it will forget after some times because we'll be seeing more prompts incoming. So we are not having any tied architecture for storing this KV cache into a lower and cheaper memory. So there are open source works like LM cache where they are offloading the KV cache into a lower tier memory. And here we did a benchmark with the disk offload. So the KV cache will be written back to the disk, and once there is a cache hit and it sees the prompt which is already computed, it will load from disk and and it will load from the disk. So here we observed a very major TTFT improvement when comparison to recomputing the entire KV cache itself, especially on long context windows. On shorter context windows, there is not much difference in it, but when the context size is around 100k tokens, we are seeing a very huge advantage. So I'll just share my screen. So here we just ran a benchmark on the two LLMs. Both the LLMs are same, but they have different KV cache storing strategies. The left-hand side one, it doesn't have any offloading of KV cache, so it stores its KV cache on the GPU memory itself. Whereas on the right-hand side, we have the LLM deployed with KV cache storing onto the disk. So if we see we have two types of queries. One, the cold queries. We already discussed, the model has seen the query for the first time, so it has to recompute the entire KV cache. Whereas the cache query, it computed, but in the case of GPU memory, it might stay on the system or it might not stay on the system. So in the baseline, we are seeing similar TTFTs for cold and cache hits. So there is, we are not using the already computed KV cache. The reason being the KV cache pulled out of the memory. We are not reusing the already computed GPU cycles. Whereas on the right hand side, we have the data being stored onto disk, and once the cache queries are coming, we are seeing a major TTFT improvement. So here nearly the improvement is on 5x scale. If you look at the absolute time difference, so we are saving nearly 13 seconds per query, which accounts for a better UX and better GPU utilization point of view. It's not only about a GPU utilization and the user experience. We are also seeing a 2x improvement in entire system power savings. So since we are not using our GPU on already computed tasks, we can use it to serve other tasks which are not computed for the first time. So this is the high level benchmark that we have. So recently there was the chip which had the model directly on the chip. So there we are seeing a throughput of around 17,000 tokens. So if I don't remember the company name, I think it's Thales or something. So the throughput was really high, but again there the problem is the hardware is embedded with the model itself. So there is no configurability of switching the model, and it's like it's a really corner case. But if we want to scale the system with higher throughput and more users on different types of models, I think we need to look at how we route this KV cache. Since the size of the KV cache is really big, to serve a 100K prompt, we need nearly 40 GB of KV cache, and it depends on the model architecture as well. Yeah, so on a high level, so that's what I had to present.
The key metric you were talking about was time to first token, and you showcased a scenario where we offloaded the KV cache to a solid state drive, which for folks are familiar. Obviously, solid state's non-volatile memory, so you're going to be able to keep your storage stored even if you have power loss. Versus where we're constrained in the market today is volatile memory, DRAM, VRAM, which is driving all the drama in the market right now. But you were basically showing that we can not only leverage solid state memory to extend our cache, KV cache context when we run out of space, but we can actually improve the time to first token when we run out of memory on the VRAM. So it doesn't have to recompute the entire footprint of context before when you're kind of memory constrained in VRAM. And then you showed the associated power savings with that as well. I think, I don't know if you did any calculation on memory savings, or is it theoretical in the sense that you could recomputate every time, and therefore it's just, a power compute savings.
Yeah.
Is there scenarios where you can generate a fixed memory savings as well, thereby lowering your fixed DRAM footprint, like in an agentic RAG scenario where you're using a DRAM footprint, you could lower your DRAM footprint, for example. Any thoughts on that, Rohit?
Right now, I can't think any of those.
Okay, so and then by the way, you just touched on kind of a recent article, and there's always a couple of these articles, whether it's at the silicon layer or at the software layer, using different techniques around quantization or binarization to reduce the size of models or accelerate the performance of models. So you were touching a little bit on that earlier, as opposed to some different techniques. I personally, I see those approaches as kind of complementary.
Yeah.
In the context that everybody's kind of looking for some alpha as it pertains to performance and accuracy, while reducing model footprint size. And now I think people are being a little bit more thoughtful about just not model footprint size, but the context that they need to keep for the model to be successful in an agent or in a single user query that really wants to make sure that they have all the context loaded to do their job. So exciting stuff, Rohit. You've been doing some great work at the forefront of that, so appreciate you coming in and sharing those numbers. Clay, well, we got you. Let's do a quick fresh stack of the week. I think Claude skills is all the rage. If you're an enterprise and you're not running on Claude, you're quickly becoming archaic, and you could do some cool things as it pertains to Claude skills these days. So I know Claude hasn't been the best as it pertains to image gen, and frankly, video gen as well is not Claude's core competency or Anthropic's core competency. So how do we fix that with Claude skills, Clay?
Yeah, totally. So this is actually a MCP server that's spun up around Nanobanamo API that's compatible with Claude's API. And what it allows us to do, like Steve, you mentioned, obviously Claude's got to really scramble in these last couple of weeks. Cybersecurity market made a big move last week based on some of the stuff that Claude was doing. But for us, we work with it a lot in the desktop app, browser. It's great. So to not have to leave that interface to generate great images is a really nice tool. So this is a pretty simple stack of the week, but I just wanted to showcase one of the images that I made yesterday in honor of our U.S. hockey team getting it done yesterday morning. I don't know if you guys watched that game, but it was pretty sweet. And so these are the boys coming out. Jack Hughes scored that final goal. It was pretty fun to watch, pretty exciting. Hasn't been done since obviously the 1980 team. So, but yeah, I was able to generate this straight from my Claude desktop interface. Just call the MCP server, and then it just gives me a URL link, and I can go and view it in the browser. So just keeping it tight, speeding up the workflows, and yeah.
Yeah, I'm definitely guilty of going, into Nanobanamo and then into Claude back and forth on image gen or workflow. So yeah, cool adder. Claude skills is increasingly being a great tool for humans and agents alike. So, we'll see what comes of it. So thanks for Rohit joining us, man. Thanks for all the great work on KV cache offloading. Massive problem, and we need to keep those models smart at scale with all the context required to do their job and affordable. So if we can reduce power, save a little bit of time to first token, recomputation time, that's huge for the market as well. So thanks, Rohit. Thanks, Clay, for a fresh stack of the week. Take care, guys.